9 o'clock. Before we get started, if you got a bulletin, there's just a whole list of people that are sick and recovering from different things. A couple of them I'll mention. Need to keep the Crosby family in our prayers. Brother Donnie, brother-in-law, had passed away. Always keep Terry. Also, we've got one coming up here. The 12th or 13th or 14th for the 16th for the tubes in the ear. So just a bunch of people to keep in our thoughts and prayers. So, Brother Trey, would you lead us in a prayer to start with, please? Yes, ma'am.
We got a call this week. Kevin is going to end up having to have surgery. We don't have any details yet. It's going to have to be done at UAB. We're just waiting on the consult.
Gut surgery.
Yeah, another resection.
Okay. Thank you.
Father, we thank you for this day you've given us to come and gather as a body of believers to learn more about you, to praise your name, to glorify you, Lord. We are so thankful for everything you give us and everything you do for us each and every day, Lord. Most of all, Lord, we are thankful for the sacrifice of your Son on the cross for the remission of our sins to open our life with you. Lord, there are a number of different individuals in the prayer list and others that aren't on the prayer list, Lord. We ask that you be with them. Those that have recently lost loved ones, those that are getting ready to go into procedures, and those that have recently had them. We ask that you are with the doctors and with the caregivers, that you bring them back to a measure of health, Lord, so that they can return safely to be with us as your family and your children. Lord, be with Larry and Terry as they deliver the lesson and the sermon today, and we ask that we open our hearts and our minds and think more about you and learn more about what we can learn to bring others to you. In your Son's name we pray. Amen.
Amen. Last week we looked at the design of the human body and went through how amazing certain parts of it. And today we're going to be looking at the design of animals. Now I want to start with Isaiah chapter 6 and verse 3. It says, "And one cried unto another and said, Holy, holy, holy is the Lord of hosts. The whole earth is full of his glory." You see, we could pick any one particular animal, insect, out of this whole world and go through it like we did last week on the human body. But we're going to do it just a little bit different. We're going to try to take several. Apologetics Press, they opened up with the bombardier beetle, and then they went to the woodpecker, and then they went to the Komodo dragon. I'm going to do things similar but a little different. I'm going to go with the bombardier beetle and the woodpecker, and then as time permits, we'll be looking at a spider, bees, and what some call a water bear, tardigrade. Now, don't let the image fool you. That little critter, you need a microscope to see the tardigrade. So, just so we're there. But we also need, before we begin the study, to understand again why we're in the study, and that goes back to 1 Peter 3:15. And if you can't quote that, it just, in paraphrasing, always be ready to give an answer. So if we're to always be ready to give an answer, that means, or implies anyway, that we should be able to give a logical answer, one that makes some sense. So if we start with Genesis 1 and verses 20 through 25, where we're going to be talking about all these creatures today, it says, "And God said, Let the waters bring forth abundantly the moving creatures that hath life, and fowl that may fly above the earth in the open firmament of heaven. And God created great whales and every living creature that moveth, which the waters brought forth abundantly after their kind, and every winged fowl after his kind. And God saw that it was good. And God blessed them, saying, Be fruitful and multiply, and fill the waters and the seas, and let the fowl multiply in the earth. And the evening and the morning were the fifth day. And God said, Let the earth bring forth the living creature after his kind, cattle and creeping things, and beasts of the earth after his kind, and it was so. And God made the beasts of the earth after his kind, and cattle after their kind, and everything that creepeth upon the earth after his kind, and God saw that it was good. So, as we go through each unique, complex characteristic of each of the following creatures that we're going to look at, we need to evaluate what is most logical. Is it most logical for it to have evolved, or is it most logical that there was a design and a plan and a creator or a maker? Y'all, I'm sure all have heard the joke that you try to play on young kids, which came first, the chicken or the egg? Well, for Bible believers, what came first? The chicken, no doubt about it. Everything that God made as an adult, full grown, ready to reproduce, and was told to go out and reproduce. In my opinion, what science wants to do when they're talking about evolving is they're wanting to start with the egg and have things scrambled up and mixed along the way and develop and develop and develop. So just keep that in the back of your mind as we go through it. Because William of Ockham, some of you may know the phrase Occam's razor. In its most basic, simple terms, what does Occam's razor, the principle of Occam's razor, mean? I'm sorry? The simplest solution is usually the right solution, or words to that effect. He went into a whole thing that said the principles giving precedence to simplicity. Of two competing theories, the simpler explanation of an entity is to be preferred. The principle is always expressed as entities are not to be multiplied beyond necessity. What do scientists do when they start adding on things and making things more complicated? They're adding on beyond the necessity of adding things on. So let's start with the bombardier beetle. There are over 500 species of this particular beetle. And the unique feature that we want to look at on it is its defense mechanism. When disturbed or agitated, they will eject a hot chemical from the tip of the abdomen, and by hot, I'm talking about 212 degrees, the boiling point. Now, so in this defense mechanism, we want to look at something. We looked at this last week when we looked at the eye and ear and other things, but I'm trying to sort of stage out my unusual phrasing to not put it all on one lesson. How many of you have ever heard of the irreducible complexity? Irreducible complexity. In its simplest terms, that just means that if you take a very complex something and remove one element, it no longer works. So you can't reduce something complex and still have it work. And that's where, and scientists make fun of us because we say, hey, that's so complex, there had to be a design, and they say we hang our hat on that and that's what we live by, and then they want to go with all these other things. So again, keep that in mind. So how does that system work? What makes that system so complex? You see, it takes a compound, and if you can look at the image there, it has several chambers. It has two chambers. One chamber holds hydrogen quinone, and the other chamber holds hydrogen peroxide. Now, when this thing gets agitated, those two chemicals go into another chamber, a mixing chamber, and on their own, those two chemicals mixed will not combust or do anything. They need 2 enzymes added to that in the combustion chamber. One dilutes one of the chemicals, and one, let me just read it to you. The 2 main chemicals. The enzymes act as catalysts to facilitate the decomposition of the hydrogen peroxide and the oxidation of the hydroquinone. Okay? So even though you got 2 chemicals going into one chamber, you've still got 2 actions that take place in that chamber for those to mix. And then it will spray out that hot liquid. Now, here's what I want you to think about for just a minute using Occam's razor. If you followed my count, how many chambers are there? 3. 2 holding, 1 mixing. How many chemicals are there? 4. 2 chemicals holding, 2 enzymes that cause those 2 to react. You've got 7 things combined now. In addition to that, this little critter has to have the knowledge to use it. And when it heats up to 212 degrees and is ejected, then the chemicals replace it to help cool it down so it won't automatically combust or degrade. So there's a whole cycle that takes place. So if we go back to Occam's razor principle, for example, which is the simplest and which is most logical? That over what the scientists say is a few million years that this little critter decided it would evolve 1 chamber. That wasn't enough. Now it'll go 2. Okay, that's a holding tank, but now I need this 3rd one. And by the way, that 3rd one, the wall of that chamber, it's not asbestos, but it's basically a chemical. It's a compound wall that can withstand some 212 degree temperature for a short period of time until it's cooled back off. So what is most logical? God said this is the way it's going to be and created it complete, or that it just strung along over a few dozen million billion years to get to where it is.
Do you remember what I said last Sunday? Things do not evolve. They are set. Because you hear of the 2-headed calf, doesn't reproduce. Nothing outside of the norm reproduces.
Yeah.
So this thing, from day one, worked.
It had to be designed complete and put together at one time. Now, I'm going to mess with your mind just a little bit because I personally believe in evolution to a point. I believe in microevolution, not macroevolution. Macro is where things cross lines, but the micro part would be that how many different dog breeds are there? And people breed dogs. Canines breed within canines and come out with different breeds. That technically is a form of evolution with the cat. But you never see a cat and a dog. You never see crossbreeding that way. Yes, sir.
The cattle, the same thing. A cow is a cow is a cow. They may be different colors, maybe a little different size. The exception is a mule. But it can't reproduce.
But yeah, I was going to say that stops that right there. So you can go to any of these creatures and within the family they can do that, but when they start mixing families, it don't happen. So just so there's no confusion on my statement about me and evolution. So what about the woodpecker? Have you ever really thought about a woodpecker? You're shaking your head this way, so you want to expound on it a little bit, or just?
I mean, I've read about it before as far as its brain being able to withstand the impact and how the structure of the skull and all that.
It's really amazing. They say, scientists, I've never counted it, but they say that a woodpecker can bang his head against a tree up to 20 times a second. And while they're foraging for the food, the beetles and all in the tree, it can be up to 1,000 times a day. So over their life expectancy of somewhere over 10 years, that's going to be into the millions of hits. Their beak is strong enough that it withstands that abuse for all those years. Let me do it a different way. This is the structure of their head, and David talked about their brain, and they have an extra thick skull, but then there are shock absorbers in there between the beak and the skull. There's a couple of places there, I think you can see and read that. But that prevents the brain damage because that shock absorber is just in the right place. You used to play ball. Have you ever seen anybody on the ball field get hit in the face hard enough their eye popped out? How come eyes don't pop out of the woodpeckers when they're beating their head against the wall? Because they blink every time they peck to keep their... So how did they know to do that? Because they had lost an eye or two once. Okay, so they have a very strong beak. They have a shock absorber. They close their eyes. Pardon?
Thick skull.
Very thick skull. So
They also have an acute sense of hearing because they're looking for that beetle or whatever.
hearing that beetle inside that tunnel that's burrowing, yes, sir. Scientists say that each strike where they hit the tree, and they did this in terms so that we could sort of understand it, they said that the impact is 1,000 times gravity, which they break down to say that it's 250 times the force that an astronaut withstands on takeoff in a rocket. That's quite a bit of force. Now, once they are beating their head against the tree, how do they keep from knocking themselves off the tree? Brother, I know, Jim, you've been on a ladder and hammer, and if you hit something hard enough, what happens if you hadn't got a real good hold on something? You're pushed back, aren't you? So how come they're not pushed off the tree? Well, God came in again. Most birds have 3 facing forward and 1 facing backward for grip. The woodpecker is 2 and 2 to give him a little bit of extra grip on that tree so he can pound away. Now, once they crack open that tunnel, how do they get the food out? How do they get that beetle that's burrowed that tunnel? They have a very long tongue. They have a tongue that's about 5 inches long, about 3 times their beak length, and it's rolled up in their skull, then stored until it's necessary. So,
The thing you have to see when you look at this is, if this didn't all work perfectly day one, the woodpecker species wouldn't have lasted very long.
No.
I mean, it had to work perfect the first day.
if he beat a hole in that tree and there's that tunnel and there's that insect he's after, and he hadn't he's got to wait 1,000 years for his tongue to develop. We've run out of species. And I don't mean to make light of some of the way that scientists look at things, but I started out by saying, which is most logical? So, yes, sir.
To go along with what you're saying as far as design, Job in chapter 12, verses 7 and 8 says, ask the beasts, they shall teach thee. Ask the fowls of the air, they shall teach thee. Or speak to the earth, and it shall teach thee, or the fishes of the sea, they shall declare unto thee. So he's using all of these examples to show that they couldn't just happen, even from the standpoint which was going to be created first as far as a male or a female. You've got to have both, very few asexual.
You can't have one develop without another one develop to mate with it. That's correct. And as far as the teaching part, when I get to the bee, I'm going to use that as an example. It's a little off our subject today, but I think it fits. So we go back to Genesis 1, 20 through 23, when he's talking with it. We've already read that talks about God doing all this. The Almighty God designed the woodpecker with a strong beak, a thick skull, a long tongue, the best shock absorber in the world, and toes facing the right direction on the foot to make it all work. Spider, my nemesis. Don't like spiders. Been bitten twice in my lifetime with brown recluse. Don't like spiders. But they are amazing. What we're going to look at today with the spider is not the, first off, how many varieties of poisonous spiders are there in the world? 0. They're venomous. And a lot of people sometimes mix up that on snakes too. There's a poisonous snake. No, there's a venomous snake. There's a little bit of difference there. But what makes the spider unique is they've got 4 to 6 spinnerets on what is normally referred to as their abdomen, where they spin a web. Some spiders don't, many do. But by the various control mechanisms they have, they control the thickness, the consistency, and the composition of those webs. For instance, they have a web type where it's soft and then it's covered with parchment type stuff called an egg sac to protect their eggs. They have another that they string out that's got sticky stuff on it so that they can capture prey. They have another type where they encapsulate their prey, and then it contracts and crushes the prey. And then they've got those that store food for later. Getting back to what Brother Day said about everything's got to work perfect on day one, what happens if that first spider confused the encapsulating, crushing prey for the egg sac? We're out of spiders before we get started. So that's the complexity of the spider. There's just a multitude of things that spiders, in the spider that way.
Larry, what's the difference between venomous and poisonous that you were talking about?
Poisonous is when you ingest it. That's poison. Venom is when it's injected into you.
Some spiders, like some snakes, they have neurotoxin, which works on nerves, and hemotoxin, which works on blood. And then they act like a poison. We think they're poisonous because they can kill us, but it's basically in terminology and application. Let's go to the honeybee. If you've ever observed a honeybee, and I know we've got some beekeepers in here, and one used to be beekeepers, They seem to always be busy doing things. And I want you to think about this for a second. I love honey. I love honey. One honeybee, a worker bee, the average lifespan is about 40 days for a worker. That's all. In its lifetime, it can produce about 1/12 of a tablespoon of honey. So it takes 12, next time you have a tablespoonful of honey, 12 bees died for that tablespoon of honey. That don't keep me from eating it. And they don't produce just enough. They produce an abundance of things. Also, natural honey, now not this processed stuff that's got all the ingredients added to it, but natural honey has an indefinite shelf life. They have discovered honey from over 5,000 years ago that's still edible because it's antimicrobial honey. So a lot of good uses. And if you go back to the Bible, what was sent to the Pharaoh or to Joseph? Best of the land, some honey. So those are interesting facts, but what do we want to look at that's the most complex part of the honeybee? I have a short video about 6 minutes, a little over 6 minutes, that we'll play that is going into how bees communicate and navigate. And the video says it a lot better than I could say it. Now, this is strictly done through a research group, and they didn't know I was going to use it in the Bible class. I used this about 10 years ago in a lesson that I did on lessons from the bee, things we can learn from the bee. So as you watch the video, again, just keep asking yourself, is it possible for something to evolve to that stage? Or had there have to be a designer? And remember also that with the worker bee only living an average of 40 days, this is something that they had knowledge that they had to be born with. It would be impossible for them to learn all this and do that work in 40 days. Video.
Aristotle was one of the first to document the intriguing behavior of honeybees. How is it, for instance, that the colony coordinates its work with activity? What appears to be a random swarming mass of life may actually be intelligent behavior.
Son, where's the volume control? Here he comes. Huh? Volume control. Okay. No.
You said it was loud.
I said it was loud enough, but they tell me to up it some.
Aristotle was one of the first to document the intriguing behavior of honeybees. How is it, for instance, that the colony coordinates its workers' activity?
More.
What appears to be a random swarming mass of life may actually be intelligent behavior. A foraging honeybee will eventually discover a new food source,
That
such
good?
as a freshly blooming flower or artificial feeder placed by a scientist. After this visit, an interesting thing happens. Over the next few minutes, many other bees arrive at the same location. They don't travel as a group. Instead, each bee finds the food source individually. How could these bees, who held no previous knowledge of this site, suddenly know precisely where the feeder was located? Is it possible that the animals communicate amongst themselves? To answer this question, Austrian biologist Karl von Frisch devised a series of experiments in the 1940s. The Researchers at Georgia Tech have reproduced Von Frisch's pioneering experiments using a modern observation hive. Two feeders are placed in different directions away from the hive. At each location, visiting honeybees are marked with a small spot of paint. A separate colour of paint is used at each station, so when a bee returns to the hive, it can easily be determined which feeding site it visited. Before Von Frisch, other scientists had observed that returning bees tended to waggle about excitedly in a figure-8 pattern before sharing the collected pollen and nectar with their hive mates. In this two-station experiment, Von Frisch noticed that the bees returning from the same feeding source danced differently from bees that arrived from the other location. While both sets of bees perform the classic figure-8 dance, the orientation of the dances is offset between the two groups. Bees returning from one feeder perform a rotated version of the dance done by the other bees. Incredibly, the angle of rotation precisely matches the angle between the feeding stations and the hive. This must be a clue to the mystery of how the bees are able to share information about the location of food. Through further experimentation, details of the grammar of the honeybee's dance language began to emerge. The dance exploits two fundamental tools available to the honeybee. First, their ability to see ultraviolet and polarized light allows them to determine the location of the sun at all times. Ultraviolet light is able to penetrate thick clouds or fog. Also, as light from the sun passes through the atmosphere, it's polarized in a direction towards the sun when viewed from the Earth. Devices like polarized film, sunglasses, or honeybee eyes can detect this orientation and determine the position of the sun even while looking in the opposite direction. This gives the bees a type of solar compass, allowing them to always know the precise position of the sun in the sky. A honeybee's entire environment seems to be constantly pointing towards the sun. In addition to this solar compass, bees possess a finely tuned internal clock. This clock is accurate enough for the bees to constantly estimate the new position of the sun as it travels across the sky. In this way, a honeybee can know the current orientation of the sun, even after spending many hours within a dark hive. They can even take into account changes in seasons or latitudes. Inside of a dark, vertically oriented beehive, the natural shared reference point is gravity, establishing both an up and a down direction. The bee's solar compass and internal clock provides another communal reference point, the sun. By pairing these two global constants, the bees form a simple language. Within the hive, the direction up, away from gravity, substitutes for the location of the sun. Then the angle that the bee dances compared to this up direction is the same angle the bee should fly away from the sun in order to find the target flower. So if the bee dances directly upward, other bees know that they can find flowers by flying directly towards the sun. If a bee dances 90 degrees to the left, then bees leaving the hive should fly 90 degrees to the left of the sun. A bee angling its dance towards the ground will let others know to fly directly away from the sun. As the day goes by, the bee will even use its internal clock to adjust for the movement of the sun in the sky. This lets fellow workers always know the correct direction to travel in order to find food. The central waggle section of the bee's dance also contains information about the distance to a food source. Longer time spent in this part of the dance means that the food is further away. Shorter durations mean that the food is closer by. In general, the bee increases the duration of this section by 1 second for every kilometre of distance to the food. When food is within several metres of the hive, this central section of the dance will shrink, causing a circular dance. For bees, distance is actually measured by the amount of energy it takes them to travel. Thus, a strong headwind could cause a bee to dance as if the food came from a further distance away. away from the sun, and 2, the duration of the middle part of the dance, which expresses the distance of a food source away from the hive. Other information, such as quality or abundance of food, might also be encoded within other parameters of the dance, or in pheromones released by the bee. Georgia Tech's multi-aim.
Rest of the video just goes in to talk about Georgia Tech and their research and all, but what'd you think of the video? Got to be designed. Can sense ultraviolet, use a compass, a clock, communicate. Very complex. Brother Golden, you got your finger going up? Yes, sir.
Well, I was going to say, I didn't see it on the film, but they say that they can photograph the surroundings of the hive, and they keep that picture like a recording, and when they come back, they see where to go, and that picture. That's how you can really mess a hive up. If you change that hive, put a brick on, they're not used to seeing that, and for a while they'll be confused.
Mm-hmm.
And also another amazing thing about the bees is normally they have a rather small cell that the queen lays an egg in, right? Well, if they're getting in need of a queen, the worker bees will enlarge that cell.
Yep.
And they'll inject a substance called royal jelly.
Right.
And that in turn forms a queen. And I don't think scientists have explained how that royal jelly does that. To me, it's just bees are amazing.
They are truly amazing. And 10 years ago when I did this lesson, I also used the bee as an example of how we become Christians by being born again. A bee has to be born twice. The queen lays an egg, and depending on need, which type egg is laid, that egg then hatches into a larva, and it's fed by the other bees until it gets to the proper size, and then it is enclosed in a cocoon, egg sac, pupa, whatever you want to phrase it. And then at the proper time, when the bee is hatched and breaks the membrane on the back that lets the wings go out and completely dry, it's only after that second birth that bee is complete and functional and a part of that, and a productive part of that hive. Yes, sir.
I had to listen to all of this to learn it. I don't guess the bees have to go to any school to learn it.
Bees don't have to go to any school to learn it. But what I had done also 10 years ago was showing that how in John 3:3, Christ was talking to Nicodemus this way and said, Jesus answered and said unto him, Verily, verily, I say unto thee, except a man be born again, he cannot see the kingdom. And then in verse 5, he tells him what that entails. Jesus answered, Verily, verily, I say unto thee, except a man be born of water and of the Spirit, he cannot enter into the kingdom of God. Yes, sir.
Also, you read about John, and he came through the desert eating locusts and honey. Honey is one of the only foods that you can have subsistence on. You can live off of honey.
Yeah.
It's one of the few foods that accomplishes that.
Honeybee is amazing. How many of you have ever looked in a microscope and seen this little creature? I called it a water bear. The technical name for it is tardigrade. I wanted to get to this for one specific reason, is that even though they're microscopic, they are one of the most resilient animals in the world. They can stand exposure to extreme temperatures. By extreme, I mean they can survive in boiling water. They can survive at almost absolute zero. They can survive extreme pressures, both ends of pressures, low and high. They're found on Himalaya mountaintops and in deep parts of the ocean. They can withstand radiation, radiation, let me see how I can phrase this. They can withstand radiation that would be 100 times strong enough to kill a human. They can do that. They can withstand dehydration, starvation. Let me just read this part here. Some of them can withstand extremely cold temperatures down to negative 460 degrees, close to absolute zero. Pressures about 6 times greater than those found in the deepest ocean trenches. Ionizing radiation at doses hundreds of times higher than the lethal dose for a human. And the vacuum of outer space. How did they evolve to withstand outer space when they had never been there? And they didn't know that they could do that until man started going up into space and then cleaning off the windows and different things and finding them and saying, hey, he's still alive.
I have one question. Since you can't obviously kill those things, are they in our drinking water? Where do they live? They're everywhere.
Technically, you can find them everywhere. They like kind of swampy areas, boggy areas more than anything else, but how did they get into space? They had to hitch a ride. Well, I say they had to hitch a ride. Some people say that, any of you ever heard the term spampermia? There are some people out there that call themselves scientists that say that all these things we find on Earth are because they come on meteorites and got here from some other place. But they had to hitch a ride to get there. And how did they wind up on something that supposedly clean that NASA had produced to go into space? Yes, sir.
God created everything good. What good does this thing do?
Well, I don't know what good a mosquito is either, or spiders that bother me. And it's ugly too. Well, it's got a face a mama would love. Anyway, they can undergo very harsh conditions, and they're one of the few groups of species that are capable of suspending their metabolism. This is actually known as cryptobiosis. And while in that state, their metabolism lowers to less than 0.01% of their normal, and their water content can drop to 1% of normal, and they can go without food or water for more than 30 years and then rehydrate and be fully functional.
What do they do?
Does it have a purpose?
To me, the purpose is educating me to know that God made things. It goes back to the Isaiah passage I read. All things are to the glory of God. So, but that's the only thing I know. I got 1 minute left. If anybody's got any other questions, comments.
No, you ruined my drinking water now.
You got other issues on your drinking water. All those nanoparticles of plastic in there. So, anybody, anything?
Everything was designed for a purpose. I don't know what some of the things that were designed for, but I do know that they had a purpose.
Well, I would say that these little critters here are on the low end of the scale, so something probably eats them. They do some cleaning of various things, and then something eats them, and right on up the line. Thank y'all so much.